Hello, welcome to the session of Plus One Mathematics. Today we are discussing Chapter 3 Trigonometric Functions Part 2. In this session, we will be discussing values of trigonometric functions, sine of trigonometric functions, graphs of trigonometric functions, trigonometric functions of sum and difference of two angles. So, first we will move on to values of trigonometric functions. So, last video we have discussed about degree radian conversion. We know that corresponding 30-degree radian measure is pi by 6, 45-degree is pi by 4, 60-degree is pi by 3, 90-degree is pi by 2, 180-degree is pi, 270-degree is 3 pi by 2 and 360-degree is 2 pi. The corresponding values of sine 30 value is 1 by 2, sine 45 is 1 by root 2, sine 60 is root 3 by 2, sine 90 is 1, then sine 180 is 0, sine 270 is minus 1 and sine 360 is 0. We can see here sine pi is 0, sine 2 pi is also 0. So, where all pi values is coming, sine is 0. Sine pi, sine 2 pi, sine 3 pi etc. becomes 0 in the case of sine. Whereas in the case of cos, the cos values are cos 0 is 1, then cos 30 is root 3 by 2, cos 45 is 1 by root 2, cos 60 is 1 by 2, cos 90 is 0, cos 270 is 0, cos 180 is minus 1, cos 360 is 1. So, we can see here cos 90 is 0, cos 270 is 0. Cos 270 means it is 3 pi by 2, cos 90 means it is pi by 2. Pi by 2, 3 pi by 2, next it will be 0 for 5 pi by 2. What does this mean? It means that all odd multiples of pi by 2 become 0 in the case of cos and all multiples of pi become 0 in the case of sine. Now, how will you get tan values? Tan values, if we are dividing sine by cos, we are getting tan. That is sine 0, cos 0. 0 by 1 is 0. Same way 1 by 2 by root 3 by 2. That is 1 by root 3. Same way 1 by root 2 by 1 by root 2 is 1. So, similarly we can find out the other values. By dividing sine by cos, we are getting tan. And the reciprocal of tan is cot. Reciprocal of tan is cot. Same way reciprocal of sine is cosec. All the cosec values will be the reciprocal of sine and all the sec values will be the reciprocal of cos. So, once we are getting sine and cos, automatically we can find out the other values very easily. So, next, which are the different quadrants? How many quadrants are there? We are having 4 different quadrants and in the first quadrant means it is from 0 to 90 degree or between 0 and pi by 2. 90 degree means it is pi by 2. So, theta between 0 and 90 means it is coming in the first quadrant. If it is between 90 and 180 or pi by 2 to pi, we call it as a second quadrant. And third quadrant, pi to 3 pi by 2. Pi between pi and 3 pi by 2, it is a third quadrant. And 3 pi by 2 to 2 pi, we call it as the fourth quadrant. So, 4 different quadrants are there. First quadrant, second quadrant, third quadrant and fourth quadrant. Each quadrant between first quadrant from 0 to pi by 2, second one from pi by 2 to pi, third one from pi to 3 pi by 2 and fourth one from 3 pi by 2 to 2 pi. Now, next is sine of trigonometric functions. What are the different sines? So there I told you there are 4 quadrants. In the first quadrant, sine, cos, tan, cosec, sec, cot, everything is positive. In the first quadrant, all are positive. Whereas in the second quadrant, sine and its reciprocal is positive. Sine is positive, cosec is positive in the second quadrant. What about in the third quadrant? Third quadrant, tan and cot is positive. Tan and its reciprocal is positive in the third quadrant. And in the fourth quadrant, you can see that cos and sec is positive in the fourth quadrant. So once again, all are positive in the first quadrant. Second quadrant, sine and its reciprocal is positive. Third quadrant, tan and its reciprocal is positive, and in the fourth quadrant we can see that cos and sec are positive. Okay. Now we are moving on to the graphs of trigonometric functions. So first graph is sin x graph. So we can see the sin x graph, and I have told you earlier sin pi is 0, sin 3 pi, sin 2 pi, sin 3 pi, sin 4 pi, sin 5 pi, negative side also. So we can see that whenever sine is having pi values, n pi, sin n pi is equal to 0. And the graph, it is repeating with a period of 2 pi. So the same graph will be repeating to the other side also. This side also same graph, this 2 pi period, that period is 2 pi, it will be repeating the whole graph. So, and it touches on the x-axis, the graph is touching on the x-axis at pi, 2 pi, 3 pi, 4 pi and so on. So, it becomes 0 because on the x-axis y value will be 0. Now, next graph is about cos x. Cos x also repeats in a period of 2 pi, and it touches on the x-axis at pi by 2, 3 pi by 2 and its odd multiples. So, cos value will be 0 for all odd multiples of pi by 2. And next one is the graph of tan x. In the case of tan x, we can see that it is going to infinity in the pi by 2 values. For pi by 2 values, tan pi by 2. Then for all multiples of pi by 2. This is the graph for Cortex. And these are just familiar with the graphs. This is y equal to cosec x graph, and this is the graph for sec x. So, from the graph we saw that sin x equal to 0 implies x is equal to n pi, and cos x equal to 0 implies x is equal to 2n plus 1 into pi by 2. So, these two are the results which we got from the graph. Then few of the important results. First result, sin square x plus cos square x equal to 1. Second one, 1 plus tan square x equal to sec square x. And third one, cosec square x equal to 1 plus cot square x. Very important identities. Sin square x plus cos square x equal to 1, 1 plus tan square x equal to sec square x, and the third one is cosec square x equal to 1 plus cot square x. Now, next we have to study about the trigonometric functions of sum and difference of two angles. If two angles are given, how can we write it as a sum and difference of different angles? Suppose the angles are x and y. Cos of x plus y can be written as cos x into cos y minus sin x into sin y. What is cos of x plus y? It is cos x cos y minus sin x sin y. Whereas cos of x minus y is cos x cos y plus sin x sin y. And sin of x plus y is sin x cos y plus cos x sin y. And sin of x minus y is sin x cos y minus cos x sin y. So, we can write it as a sum and difference of angles. Same way in the case of tan. Tan of x plus y also we can write. That is tan x plus tan y divided by 1 minus tan x into tan y. Same way, tan of x minus y can be written as tan x minus tan y divided by 1 plus tan x into tan y. Similarly, we can find what is cot of x plus y, cot of x minus y, cos pi by 2 plus x, cos pi by 2 minus x. These all values we can find out from that. That is, by substituting values for x and y, we can find out all these results, and which will be used in the problems. Now next is double angle identities. Double angle means instead of x, we are using here 2x. What is sine 2x? Sine 2x is 2 sin x into cos x. And cos 2x is cos square x minus sine square x. We are having more identities for cos 2x. One is cos square x minus sine square x. Another one is 2 cos square x minus 1. And another result is 1 minus 2 sine square x are the different results for cos 2x. So, cos 2x is cos square x minus sine square x, 2 cos square x minus 1 and 1 minus 2 sine square x. Same way tan 2x. Tan 2x is 2 tan x by 1 minus tan square x. These are called the double angle identities. That is, angles multiplied by 2. Now there are few more results for sine. Angles multiplied by 3. That is sine 3x. Sine 3x is 3 sin x minus 4 sin cube x. Cos 3x equal to 4 cos cube x minus 3 cos x. And tan 3x equal to 3 tan x minus tan cube x divided by 1 minus 3 tan square x. So in all these results you can see that instead of x it is 3x. Angles are all multiplied by 3. So we have to study what is sine 3x, cos 3x and tan 3x. These are standard results which can be applied in the problems. Now here we can see cos x plus cos y, that is, we can write it as a sum and convert into product. Sum of trigonometric functions can be changed into product of trigonometric functions. How can you change? Cos x plus cos y can be written as 2 cos x plus y by 2 into cos x minus y by 2. Same way, cos x minus cos y is the same as minus 2 sin x plus y by 2 into sin x minus y by 2. Same way, sin x plus sin y is equal to 2 sin x plus y by 2 into cos x minus y by 2. Similarly, sin x minus sin y is equal to 2 cos x plus y by 2 into sin x minus y by 2. So, here it is a sum of trigonometric functions, whereas the other side it is the product. So, sum or difference of trigonometric functions we can convert into product of trigonometric functions. So, now we will move on to the problems. Show that tan 3x into tan 2x into tan x equal to tan 3x minus tan 2x minus tan x. How can we prove this? This we can start with the greater value. Greater value is 3x. So, 3x can be written as 2x plus x. 3x is the same as 2x plus x. And I am applying tan on both sides. So, it becomes tan 3x equal to tan of 2x plus x. Now, applying tan of x plus y. Tan of x plus y is tan x plus tan y divided by 1 minus tan x into tan y. Same way, here instead of x and y, it is 2x and x. So, we can write this as tan 2x plus tan x divided by 1 minus tan 2x into tan x. So, now what you have to do? You have to cross multiply. Cross multiplying, we are getting tan 3x into 1 minus tan 2x into tan x. Expand, open the bracket, we are getting tan 3x minus tan 3x into tan 2x into tan x is equal to tan 2x plus tan x. So, that is after cross multiplication. Now, we can rearrange and get the answer as tan 3x tan 2x into tan x is equal to tan 3x minus tan 2x minus tan x. One more example, find the value of sine 75 degree. How can you find what is sine 75? Always start with the known values. So, 75 degree is the same as 45 degree plus 30 degree, and that is sine of 45 plus 30, sine of x plus y. Sine of 45 plus 30 can be written as using sine of x plus y, that is sine x cos y plus cos x sin y. So, that sine of 45 plus 30 is the same as sine 45 cos 30 plus cos 45 sin 30. Now, directly we can substitute the values here. Sine 45 is 1 by root 2, cos 30 is root 3 by 2 plus cos 45 and sin 30 values you can substitute and simplify the answer. Always start with the known values. So, if you are writing starting with the known values, it will be easy for you. Otherwise, it will be without knowing the values, it will be difficult to substitute. So, try to start with the known values. So, try out more problems and make the basics of this trigonometric functions thorough. Thank you.